Welcome to the Grasshopper tutorial introducing the concept of lists and structures. So imagine you're at a school dance, and typically at a school dance, you have the guys and the gals. And so I created a list of guys and gals. So the list of guys, we have John, Tom, Ron, Don, Aaron, Baron, Sean, and Billy Bob. And the list of girls is Jessie, Josie, Peggy, Letty, Betty, Evie, Dixie, and Sunny. And so this group of guys and this group of gals, they came to the dance as like these groups, and they need a partner to dance with. So how do we make sure that these two groups find the right partner? So this is where the idea of merging comes in. So typically, to take these two lists, you would take one list and you use the merge command to combine two things. But in the way that the list is currently structured right now, it doesn't really pair anyone with anyone. It just dumps all these people into one giant list. And the reason this is the case is because this list here is what's known as a flattened list. So you know about the terms graphed and flattening. This list here is a flattened condition, which means basically all the items in the list exist within one tree structure, within one tree branch. So if I apply the flatten command to this, it creates the exact same list. What we need to do is we need to apply a tool called grafting. And grafting, what that does is it gives each item in the list its own tree branch. So if I use this graph command here, you see what this little viewer thing here shows is basically it gives each item its own individual branch. And so you can see literally it's a branch. So by doing this, it gives each person in this dance basically their own, I guess you can say their own dance number, so to speak. And they can have a matching dance number to the gals. So what we do is we pull the graph over here, and we have a matching list, right? Matching list structure. And then if we use the merge command now with these grafted lists, like so, you will see that we have a nice list that matches each guy with each gal in this dance. So John is with Jessie, Tom with Josie, Ron with Peggy, on and on and on. So that's great. Now, the whole thing about this is that it just kind of matches them based off of the list of the order of this list here. So let's imagine this group of guys came in all together and they just randomly wrote their names in this, say, the guest register. And same with this one here. So all they really did in terms of matching the guy and the gals, they just went, all right, you went first and you went first, and you get both of you match together. But as we all know, people all have different heights. And so, if you're going to dance in pairs, you probably want to dance with someone who is of a similar size as you, because that just makes it a little bit easier, especially when you're just getting started. And so I have also imagined in this fake scenario that in addition to everyone writing their name down, they also wrote their height down. And so I just did feet, and I just did decimal feet just to make it easier. And so now what we want to do is we want to take this information here and we want to combine it with this information here. And just so we understand, like, for instance, John is 5.9 feet. There's a tool called concact, basically, that allows us to combine strings together and create a new way of representing this data here. So what this does is basically it allows me to take this list here. Let me just delete these guys for a second and take this list here and create a new list that combines those two together. So you have the name and the height of the person all together in one data structure. So it's a little bit easier to understand that this person is 5.9 feet. What you can actually do with this as well is you can add spaces and other text items to help make this a little bit clearer. So you can see right now it would make more sense if there was a space between these two. So what I'll simply do is I create a panel, double click in here, type in my space bar, which is just basically one space. And then if I put that in between those two things there, now you get a nice space in between the two. And then, maybe you want a little unit identifier so, you can understand that this is a foot. So I just put that there. Then we have John is 5.9 feet, yada, yada, yada. And so I won't do it for the ladies, but you can imagine the same thing being done for them. So now we know each person's height. I'm going to quickly do that right here for as the next thing right here. So this is the guys, and This is the gals. So what we want to do now is we want to take each of these lists here, and we want to match basically each person with the person who's most similar in terms of their height. And so what I'm going to do is we're going to sort these lists based off the height of the person. So what I'm first do is basically use the sorting function here, and I'll sort the list of heights using that cable there. So what this does now, as you can see, it basically takes that list there and it sorts it. Excuse me. I just had my sandwich and spicy sandwich. It takes that list and it sorts it from smallest to largest. You can actually sort another list synchronously with this one. So it allows you to take this list here, and what it does is it matches the index of this list, that list there, so that basically, if I do this, you can get the sorted list of this to match that. So now we have a updated list of the gentlemen, and what I'll do is I'll use this one instead here, so that we have the updated list of the gentlemen with their updated heights. And let's do the exact same thing with the gals, the lovely ladies. So what we'll do is we'll sort their heights and then sort their names so that we have an updated list of guys and gals. And then we'll simply do at this point is we'll do the exact same thing, which is to use the graph command to put them into their own little trees. Here we go. And now, as you can see, we have sorted the list of people with their respective partners, and their heights are now matched to the person that is the most similar height to them. So what we did is we took data that was once just a mess. We used the sorting and list commands here to basically put them in an order that makes sense, and then we grafted these trees so that we can match each person with the person of their respective height index there. So that's all cool and fun, and then we could just have more fun with this and begin to sort people as we go through this thing. But essentially, that's kind of the main idea. Is like, number one, lists and structures are really the foundation of Grasshopper and understanding how you manage these things, and also combine lists of different types together in order to create new data. This is really what you need to learn how to do when Grasshopper comes along. The last thing I'll show you guys is this. Let's say you wanted to create another list here, and instead of a nice dance, this is a mosh pit, and so no one's really cares about where they are. So maybe instead, what you would do is you would just like use a flatten command here, and just take these guys, these gals, put them together in one giant list like so. Oops, you can see that. And I'm gonna use a command that I like to use a lot, which to add some randomness is the jitter. It's just literally a dance too. So we put the dance command in here. And what this does is it allows us to take that whole list and just shift it around. And then we can also add a randomizer and a random seed there to kind of like create a list here. So this is all those people dancing, just getting crazy. Definitely not social distancing, so they're all going to get the virus and spread it to the community. So as we all know, mosh pits are one of the most dangerous things that you can partake in today's virus-laden society, and I would not recommend anyone join a mosh pit. And so that's my main takeaway of today's tutorial: is to don't go into mosh pits, and that's my tutorial.